Relativity of simultaneity. Consider two frames of references S and S dash having common x-axis. The frame S dash is moving along positive x direction with the uniform velocity v relative to the frame S which is at rest. The two events, example explosion of a pair of a time bomb, occur in the frame S at the same instant, that is t0, to the observer O in the frame, that is S. Let two events occur. Let the two events occur at the different locations at a distance x1 and x2 from O. Means from the observer O, the two events occurring at a distance x1 and x2 from the observer O. The same two events as measured by O dash in the frame S dash appear to occur at a time are given by the expression. For the same two events, the time is measured by the observer O dash in the frame, that is S dash. If you write here T1 dash is equal to T0 minus Vx1 divided by C square divided by root of 1 minus V square by C square, this is equation 1, and T2 dash is equal to T0 minus Vx by Vx2 divided by C square root of 1 minus V square by C square, this is equation 2. The time interval T dash between two events as observed by the observer O dash, difference in time of these two, T dash equal to T2 dash minus T1 dash, and after simplification we are going to get the term V into x2 x1 minus x2 divided by C square divided by root of 1 minus V square by C square, this is equation, that is the 3. From the above equation it is clear that the T1 dash is not equal to, that is T2 dash. Means if two events occur simultaneously for the observer in S, do not appear simultaneously in S dash frame. Therefore, concept of simultaneity has only relative, not absolute. The two events that appear simultaneously in S dash S will observe to be simultaneous in S dash only if they occur at the same point x1 is equal to x2. The relativistic velocity transformation, or that is addition of velocities. Consider two frames of references S and S dash having common x-axis. The frame S dash is moving along positive x-axis direction with a uniform velocity v relative to the frame S which is at rest. Consider an object like aeroplane is moving along positive x-axis direction in the frame, that is S dash. Suppose the observer at O in the frame S finds that the body moving through a distance dx in a time that is dt, and similarly observer O dash in the frame S dash finds the same body moves through a distance the dx dash in a time that is dt dash. Then we can write velocity is equal to distance by time. Means the velocity of this aeroplane as measured by the observer O in the frame S, that is u, and also that is u dash is equal to dx dash by dt is the velocity. U dash is the velocity as measured by the observer O dash in the frame, that is the S dash. Then by Lorentz transformation equations we have, that is x dash is equal to x minus vt divided by root of 1 minus v square by c square, and also t dash equal to t minus vx divided by, that is c square divided by root of 1 minus v square by c square. Okay, right, differentiate these two equations. Right, differentiating above equations we get, that is dx dash is equal to dx minus v into dt divided by root of 1 minus v square by c square, this is equation 1. Once again differentiate this, dt dash is equal to dt minus v into dx divided by c square divided by root of 1 minus v square by c square, this is equation 2. Then dividing equation 1 by 2, dividing dx dash by, that is dt, and we are getting the term dx minus v dt divided by dt minus v into dx by, that is c square. Now you divide this denominator and numerator by, that is dt. dx by that is dt minus v divided by dt minus v by c square into dx by dt. This is equal to dx by dt is equal to velocity u minus v divided by 1 minus uv by c square. Then we can write this is as u dash is equal to u minus v divided by 1 minus uv by c square. This is the law of addition of velocities known as the relativistic velocity transformation. Now, u dash is the velocity as measured from the moving system s dash and expressed in terms of velocity observed from the stationary system s. Similarly, an observer in the frame s finds the velocity of the body as u is equal to u dash plus v divided by that is 1 plus u v u dash divided by c square.